What is a crystallization? Crystallization is a chemical process that forms pure solid crystals, used to separate and purify components of homogeneous mixtures. To better understand this concept, an experiment of crystallization was conducted. The materials needed are copper sulfate, distilled water, beaker, petri dish, spatula, scale, heating plate, filter paper, funnel, and magnetic stir. The process is: for the initial preparation, it is necessary to weigh 31 grams of copper sulfate using the scale. Then measure 60 milliliters of distilled water. Then we need to heat in the water. Place the distilled water in a beaker and heat it on a heating plate. Carefully control the temperature, making sure it doesn't exceed 17 degrees Celsius. That is to prevent decomposition of the sulfate and ensure well-formed crystals. For preparing the solution, once the optimal temperature is reached, add the copper sulfate to the hot water. The water should be hot to improve the solubility of the copper sulfate and have it dissolve. Stir manually for a few minutes to help the initial dissolution. Finally, place a magnetic stir bar in the beaker and turn on the magnetic stir to ensure that the copper sulfate fully dissolves and the solution becomes super saturated. That is important to continue monitoring the temperature. The filtration. Using a filter paper and a funnel, filter the solution to remove impurities. In this part, we need to divide in the solution. Pour the obtained liquid into two containers, a petri dish and a beaker. In the beaker, introduce a raw medium, such as a thread or a thread with a crystal, to act as a nucleation center, promoting ordered crystal growth. The crystal growth. Let the container sit in an stable pace, avoiding movements or sudden temperature changes. The crystal growth may take between 24 and 84 hours. What are the initial results? After the waiting time, small crystals are observed in both containers. After the required time, the crystals will grow to a later sizes, depending on the supersaturation conditions and the system stability.